In this video, we're going to prove that if L is a linear transformation from Rn to Rm, let me write that down somewhere because I don't want to forget that. Okay, so L is a linear transformation from Rn to Rm. Then there exists a unique n by n matrix A such that L of x and A times x are equal for all x in Rn. Okay, so let us pick this arbitrary element in Rn. That is, let us pick x. Let x equal to, don't want to say x1, x2. I think that's going to be too messy. How about c1, c2 up to cn? Remember, you take L of things in R sub n. Now, this here is equal to C1 times the vector E1 plus C2 times E sub 2 all the way up to C sub n times E sub n, where E sub I is the ith column entry, is the II position of the identity matrix. 0, 0, and then then 1, and then all zeros, where that's the ith row. Okay. So, but basically, you have C1 times 1, 0, 0, 0 forever, plus C2 times 0, 1, and then zeros forever, and then C3, 0, 0, 1, and then zeros forever, and we continue this. If you just add those first three, you get C1 and then all zeros. This product will be 0, C2, and then all zeros, and then C3 times 0 is 0, C3 times 0 is still 0, C3 times 1 is 1, is C3, and then times a lot of zeros is all zeros. And if you add up just these three, you'll get C1, C2, C3, and all zeros. But the rest of them will fill them in. It'll give you C4, C5, etc. Not going to prove this. Okay. So now, what is L of x? Well, L of x is L of anything that equals x. And this equals x. So it's L of C1. And remember, C1 is just a real number. C2 is a real number. Cn is a real number. So C1 times vector E1. The C1 is like a scalar. C2, E sub 2, all the way down to C sub n, E sub n. But this, using some properties and theorems of our linear transformations, this is C1 L of E1 plus C sub 2 L of E2 all the way down to Cn L of E sub n. Now remember, L goes from Rn to Rm. So L of E1 is going to be an R sub n. Let's say that it equals to, I'll let the second component be 1. Always let the second component be 1 for E1. So first row, second row, or mth row. And L of E sub 2 will equal to A1, 2, A2, 2, down to AM2. All the way down to L of E sub n will equal to A1n, A2n, down to AMN. n. Okay. So, again, we want to show that ax is equal to L of x. And we have part of it. L of x is equal to that. Where L of E1 is this mess, L of E2 is this mess. So let's actually continue. Oops. This equal sign comes down here. We have C1 times L of E1. But L of E1 is A11, A21, down to AM1. Plus C2, L of E2. But L of E2 is right above us. It's A12, A22, down to AM2. All the way down to plus C sub n, L of En. But L of En is right there. It's A1n, A2 sub n, down to A sub mn. And maybe we'll multiply this. So we get C1, A11, C1, A21, C down to C1, AM sub 1, plus C sub 2 times A12, oops, supposed to be doing that multiplication. C2, C2, all the way down to C sub 2, AM sub 2, plus all the way down to C sub n, A sub 1n, C sub n times A2n, all the way down to Cn times AMN. Now, this here is nothing more than C1 A11 plus C2 A12 dot 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 up to C sub n A1n. And then the second entry, second row, would be C1 A21 plus C sub 2 A22 plus etc. down to Cn A2n. All the way continuing in this fashion all the way to the last one, which is C1 AM1 plus C2 AM sub 2 all the way down to CM AMN. So keep in mind that this is just one column. Okay, that's not n columns. When you add those, you get one real number. But we do have m rows. This is the number of rows, which is m, by the number of columns. This is m by 1, which is good because with something in Rm is m by 1. So now what we have is that this is equal to L of x. This is equal to L of x. But this is the same as A11, A12, all the way down to A1n, A21, A22, all the way down to A2n, dot, 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 AM1, AM2, up to AMN. Now, if you multiply this by x, that is C1, C2, all the way down to Cn, I maintain that you're going to get this. That is, this matrix is A, and there's our X. Let's verify that. If you actually multiplied the first row by the one and only one column, you'd get C1 A11 plus C sub 2 A12 all the way down to C sub n A1n. Exactly this. If you multiply this row by the one and only one column, you get A21 times C1 plus A22 times C2 all the way down to this times that, Cn A2n. Exactly the second column. Okay? So, we found our A. We found our A. A is equal to A11, A12, up to A1n, A21, A22, up to A2 sub n, all the way down to AM1, AM2, all the way down to AMN. That's A. And you know what? It's the only one that we found. That completes this video. If you just love videos like this where everything is proven, subscribe to my channel. If you have a video you'd like for me to make up, leave it in the comment section. If you have a different type of comment to leave, go for it. Leave the comment. Good or bad, I like them all. Most of all, watch and learn.